Swayam Prabha. Digital India. Educated India.
Dear learners, I am Dr. Renuka Mainde, corporate nutritionist, academic counselor in IGNOU for their MSc DFSM course. Learners, the learning objective of present module are: describe and understand structure of egg, explain the composition and nutritive value of egg, discuss the egg protein, discuss the characteristics of egg, explain the deterioration of egg, explain the difference between broiler and layers. Let's begin. Egg have been used as food since ancient time. Eggs from hen is commonly consumed throughout the world. Egg is an important source of nourishment at affordable price. Different egg delicacies can be included in the diet. Egg proteins are considered by the WHO to be the reference protein to which all other proteins are compared. Eggs are rich source of almost all nutrients except vitamin C. Egg contains protein of excellent quality. Therefore, they are specially recommended for growing children, pregnant women, and lactating mothers. Eggs are among the best dietary source of choline. Eggs are high in antioxidant lutein and zeaxanthin, which helps to prevent macular degeneration. Egg protein helps in improving the satiety, hence may promote weight loss too. Let's understand the structure of egg. An average chicken egg weighs about 57 grams. The parts of an egg are yolk, the white, the shell membrane, and the shell. An egg consists of a yolk at the center, surrounded by albumin, both of which are enclosed within the shell. Let us understand the structure of eggshell. It is the outer covering of an egg which consists of pores. The air gets in through the pores for the embryo to breathe. These are approximately 7,500 pores per egg. The size of pores is big at the broader end of egg. Eggshell. The outer surface of the shell is covered with cuticle which seals the pores and checks outer temperature and prevents carbon dioxide to escape from the egg. The shell also consists of inner and outer shell membrane. The air cell is formed between the shell membranes, usually at the broader end of the egg. The outer shell membrane is the air cell membrane. The true shell of eggs is built in columns of calcium carbonate from individual seeding sites on the membranes. The shell is rigid but brittle. Shell strength is determined not only by shell thickness but also by shape and structure. The outermost part of the shell is the cuticle, which gives the egg its characteristics bloom or shine. When the egg is laid, the cuticle is still moist, although it will dry within a minute or two. The cuticle normally covers the pores, and this provides extra microbiological protection, especially when the egg is fresh. Let us understand albumin. The white portion or albumin of an egg constitutes about 58 to 60% of egg weight. has three distinct layers of outer thin, middle dense and inner thin liquid. It also consists of chalazae, which is attached to chalaziferous layers. The chalaziferous layer is around the yolk. Egg albumin is rich in protein and vitamins, and it contains substance which protect the egg from microorganisms which may have entered through the shell. In freshly laid, good quality egg, alternating layers of thick and thin albumin are clearly visible. The innermost layer of thick albumin, that is chalaziferous layer, is extended at 2 points, forming the white fibrous chalazae which are anchored in the outer thick albumin. The structure of the albumin is designed to provide support and protection to the yolk, holding it centrally inside the egg. Albumin quality is often measured as function of the height of the inner thick albumin. The major factor in determining albumin height is egg storage time and conditions. The effect of storage on egg quality can also be measured by increase in albumin pH. Let us understand the structure of yolk. Yolk, the yellow portion or a yolk of an egg, constitutes around 31% of egg weight, has following layers. Yolk consists of germinal disc, lead bra, concentric rings of yolk material and vitelline membrane. Lead bra, the white yolk which connects the germinal disc with the center of the yolk. Light yolk layer. No dietary pigment is available. Dark yolk layer. The color is dark yellow due to the periodic deposition of carotenoid pigment. Yolk membrane, it is also called as vitelline, which surrounds the yolk. Blastodisc, germinal disc. The germinal disc is also known as blastoderm in the fertile egg and blastodisc in non-fertile eggs. Portion of lead bra known as nucleus of Pander, which is connected with its neck to the center of the yolk. Let us understand air cell. There is no air cell in a fresh egg at the moment it is laid. The moment the content contracts following cooling, slight vacuum is created, drawing air through its pores and give rise to an air cell between the two shell membranes. The size varies with the duration of holding egg and the species of bird. Learners, let us understand chemical composition of egg. White, 60% of total egg weight. Chalaziferous, inner thin, outer thick and outer thin albumin. The total solid content of albumin is 11 to 12%. Yolk, 30 to 33% of total egg weight and composed of vitelline membrane and yolk. Total solid contents of yolk is about 50 to 52%. Shell, 9 to 12%. The total egg weight largely consists of calcium carbonate, which is approximately 94%. Magnesium carbonate 1%, calcium phosphate 1% and organic matter 4%. On weight basis, Egg consists of around 11% shell, 58% albumin and 31% yolk. Minor variation do occur due to factors such as breed, age of a bird, nutrition and disease. Learners, let's study now nutritive value of egg. Eggs are considered as delicacy and recognized as important protective food from ancient times. Eggs are rich in easily digestible fat, high quality protein, good source of vitamins and valuable source of minerals. Eggs are palatable and useful in special diets and indispensable in cookery practices. Traces of carbohydrate is present in egg content which reacts with egg protein during cooking, causing Maillard reaction, especially in egg powder manufacture. Types of lipids are phospholipids, that is 32.8%, sterols 4.9%, and neutral fats 62.3%. Fatty acids are palmitic, stearic, linolenic, linoleic, and arachidonic acids. Egg is a rich source of quality protein, important source of unsaturated fatty acids, that is oleic acid, iron, phosphorus, trace minerals, vitamin A, E, K and B complex vitamins, especially vitamin B. As a source of vitamin D, egg rank second to fish liver oils. Eggs are low in calcium, present only in shell and have no vitamin C. Egg is low in calories and easy digestibility. Egg can be included in the diet of older people. Egg protein and emulsified fat are most suitable for babies and growing children. Egg finds a place in everyone's diet. Value-added lipids of egg. Phospholipids are composed of glycerol 2 fatty acid phosphate soluble in water and are manufactured in our bodies. Let us understand value-added lipids of eggs. Each glycerophospholipid include polar region, glycerol, carbonyl of fatty acids. The polar head groups and non-polar hydrocarbon tails of fatty acids. Let us understand lipids of egg. Sphingolipids, hydrolyzed throughout the gastrointestinal tract to the same categories of metabolites that are used by cells to regulate growth, differentiation, apoptosis, and other cellular functions. Feeding sphingolipids inhibits colon carcinogenesis, reduces serum LDL cholesterol, elevates HDL cholesterol, suggesting that sphingolipids represents a functional constituent of food. Sphingolipids. Sphingolipids also have a polar head group and two non-polar tails but do not contain glycerol. Instead, the backbone is sphingosine, a long-chain amino alcohol. Sphingomyelin, important for formation and maintenance of lipid rafts. Lipid rafts are involved in various signaling, including immunological responses and transportation of specific materials plays important roles in the expression of specific cellular functions such as intracellular information, transmission, and maintenance of membrane structure. Despite containing long-chain fatty acid, sphingomyelins uniquely suitable for the formation of liposomes. Let us now learn about egg proteins. The egg proteins are easily digested and its biological value is high as compared to other foods. Biological value of egg protein is 100, indicating all of the proteins consumed is retained by the body. Egg white, also known as albumin, contributes to 60% total proteins present in egg and the rest is from yolk. Nearly 50% of the protein in egg white is of albumin, followed by corn albumin 13%, ovomucoid 10%, lysozymes 3.5%, ovomucin 2%, avidin, ovoglobulin and ovoinhibitor. Vitelline is the protein present in egg yolk which is present in lipoprotein complex as lipovitelline. Phosphatine, phosphorus containing and lifetine sulfur containing protein are also present in egg yolk. Avidin is a protein present in egg white which binds vitamin biotin, thus makes it unavailable to the body. All egg white proteins are globular. Globular proteins are important for forming properties of egg white. Different egg white proteins are as follows. Of albumin, it is the main protein constituent. It is 55% of the protein of egg white and is a phosphoglycoprotein. The carbohydrate components of albumin are mannose and glucosamine. Of albumin in solution denatures by mechanical agitation but is resistant to thermal denaturation. Corn albumin, it constitutes 13% of protein egg albumin. Corn albumin complex with iron, making iron unavailable to the system. Corn albumin is easily heat coagulated. Egg white protein, ovomucoid, it constitutes 10% of the egg white protein. Ovomucoid is a trypsin inhibitor. Ovomucin, it is responsible for the thickness of albumin and largely present in thick albumin and is insoluble in water but soluble in dilute salt solution. Lysozyme, it acts as an antibacterial by dissolving the cells of bacteria. Lysozyme is heat resistant. Avidin, it binds biotin and makes the vitamin biotin unavailable to the system. Let us understand egg yolk proteins. Phosphatine, it is rich in phosphorus. It accounts for 80% of the protein of yolk. It binds tightly ferric iron and forms a soluble complex and thus is the iron carrier of yolk. Lipovitellins, these are high density proteins separated into two fractions. The alpha and beta lipovitellins contains 40% neutral lipids and 60% phospholipids. Egg yolk protein, lifetine, it has three components, alpha, beta and gamma lifetine. This differs in their molecular weight. Low density lipoprotein, egg yolk consists of 74% neutral lipids and 25% phospholipids. it can be separated to two components, LDL and LD2. Flavoprotein. All riboflavin in egg albumin is bound in the flavoprotein in 1:1 ratio. It ensures transfer of riboflavin from the blood serum to the albumin in the egg white bound to an apoprotein called flavoprotein. Flavoprotein. The apoprotein is acidic with molecular weight of 32 to 36 kilodalton and contain a carbohydrate moiety 14% made up of mannose, galactose, glucosamine, 7 to 8 phosphate groups and 8 disulfide bonds. 1 mole of apoprotein binds 1 mole of riboflavin, but this binding ability is lost when the protein is exposed to a pH below its isoelectric pH. Minerals of egg. Eggshell is the major source of calcium present in the egg. Calcium is present significantly in egg yolk but less in albumin. Other minerals present in yolk and albumin are sodium, potassium, magnesium, sulfur and chlorine. The minerals content of eggs depends on mineral content of the feed of chicken. Egg yolk is a highly bioavailable source of lutein and zeaxanthin. Sweet yellow corn, egg yolk, kiwi fruit, pumpkin, zucchini, spinach, squash, grapes and peas are also rich in carotenoids. Changes during cooking of egg. Eggs are often cooked and served as the main protein dish in a meal and also used in making number of dishes like custard, cutlets, etc. Certain properties like color, flavor, viscosity and coagulability makes eggs valuable in various cooking processes. Protein coagulates during heating, thus bringing about thickening as in custard, sauces and puddings. At high temperature, coagulation is very rapid. However, addition of substances like milk, sugar, etc. slows the rate of coagulation. The egg protein coagulates, thus binding the mixture and holding the breadcrumbs to give crust formation. Application of heat. The egg protein is also good emulsifying agent and is used extensively in the preparation of mayonnaise, cheese soufflés. Eggs are used for leavening food mixtures too. Beating egg white, it becomes fluffy. This is due to the incorporation of air in the mixture. The presence of air in baked products like sponge cake makes the product soft and spongy. Characteristics of fresh egg. Egg is an excellent food and hence its quality is of very great importance. Fresh eggs have best quality. Quality of egg can be determined by many factors. Size. By weight, one can find out the quality. The normal weight of an egg is 40 to 70 gram. The weight depends on the inheritance, stage of laying, season of laying, age, diet and health of the bird. The size does not at times reflect the quality. Usually, small egg contains higher proportion of yolk than large eggs. Shell. Though this part is not consumed, its condition is important because of the protection it gives to the edible portion. The factors to be considered are its strength, porosity, and cleanliness. The strength of the shell depends upon its thickness. The strength of the shell depends upon its thickness, which in turn depends on the nutrition of the bird. A high porosity of the eggshell will speed up the deterioration on the quality of egg contents. It permits the evaporation of moisture and allows dissolved carbon dioxide to escape from the contents during the storage of egg. The texture of the shell does not affect the quality of inner content. Any dirt on the eggshell means the presence of the large number of contaminated microorganisms. Weak shell, rough handling results in damage to the shell. Good egg should not be unbroken. Air cell. As the quality of the egg deteriorates, the size of the air cell increases due to the loss of moisture through the cell, especially in warm, dry atmosphere. In good quality egg, the depth of the air cell is 1 by 8 or 3 by 16 inches. In poor quality, the depth of the cell would be more than 3/8 of an inch. Egg white. A fresh egg, when broken onto a plate, stands up in the rounded form due to the viscosity of the thick portion of egg white that surrounds the yolk. As egg deteriorates, the percentage of the thin white increases, possibly due to proteolysis reduction of SS bond and interaction of mucin and lysozyme. The increase in thinning correlates with an increase in alkalinity and alkaline hydrolysis of the disulfide bonds of ovomucin to yield a lower molecular weight protein. As the quality deteriorates, the pH of white increases from 7.6 to 9.7. There is a loss of carbon dioxide also. Increase in alkaline also decreases the volumes of cake. Egg yolk. In deteriorated egg, the yolk also takes up water from the white and yolk membrane. Vitelline membrane stretches, and when broken onto a plate, the deteriorated egg flattens and tends to spread over the plate. If stretched excessively by movement of water into the yolk membrane is weakened and may break when yolk is removed from the shell. Characteristics of fresh egg. Separation of the yolk from the white is thus difficult or impossible. Yolks of fresh eggs are slightly acidic pH, that is 6 to 6.2, and as there is increased loss of carbon dioxide, alkalinity is increased. The pH of the eggs may be kept lower or less alkaline during storage if the eggshell are coated with thin layer of oil. Deterioration of egg. Fertile eggs gets deteriorated more rapidly than infertile egg. Eggs, when stored at room temperature, undergo deteriorative changes. The weakening of the yolk membrane occurs after 2 days at 37 degrees centigrade or after 5 days at 25 degrees centigrade or 20 days in 16 degrees centigrade, 100 days at 2 degrees centigrade. These changes that occur during deterioration may be grouped as physical and chemical changes. Physical changes. Egg white becomes less viscous and spreads rapidly. The size of the air cell increases due to the moisture loss during storage. Water passes from the white to the yolk, thus increasing the volume and water content of the yolk, resulting in breaking of vitelline membrane. Chemical changes: loss of water, loss of carbon dioxide, change in pH from 7.6 to 9.7 in egg white, the breakdown of protein, increase in the amount of free ammonia, increase in water-soluble inorganic phosphorus compound, increase in free fatty acid in yolk fat, deterioration in the flavor of eggs occurs by the invasion of microorganisms and by the changes that take place in fat and proteins. Bacterial decomposition. As an egg ages, the porosity of the cell increases, making possible the infiltration of bacteria and molds. The alkalinity of egg white and lysozyme serve to reduce this spoilage caused by the microorganisms. Let us understand the difference between broilers and layers. India has vast resource of livestock and poultry which plays a vital role in improving socio-economic condition of rural masses. India's poultry population is 489.01 million head and ranks 4th in duck and 5th in chicken in the world. Chicken are the most popular among the domesticated poultry species and account for 92% of the total poultry population in India. Broiler, immature young chicken of either sex with tender meat, soft, pliable, smooth textured skin and flexible breastbone cartilage of about 6 weeks of age. Layer, a mature female fowl which has been kept for egg laying purpose, 21 to 72 weeks of age, especially those are in current production. An adult commercial chicken of 21 to 72 weeks of age and produces most of the eggs for consumption. Chicken farming. In chicken farming, upon the requirement of meat and eggs in the area, a farmer may opt for starting either broiler farming for meat or layer farming for eggs. Besides the nutritive value, eggs have many industrial uses in the preparation of adhesive, printers, ink, shampoo, soap, vaccines, etc. The eggshells are used as mineral feed for animals and birds. The feathers are used for making cushion, mattresses, pillows, etc. Let's conclude, learners. Egg have been used as a food since ancient time. Eggs from hen is commonly consumed throughout the world. Egg is an important source of nourishment at affordable price. The white portion or albumen of an egg constitutes about 58 to 60% of egg weight, has three distinct layers of outer thin, middle dense and inner thin liquid. Yolk, the yellow portion or yolk of an egg constitutes around 31% of egg weight, has following layers. Yolk consists of germinal disc, lead-bra, concentric rings of yolk material and vitelline membrane. White, 60% of total egg weight. Calciferous, inner thin layer, outer thick and outer thin albumen. On a weight basis, the egg consists of around 11% shell, 58% albumin, and 31% yolk. Egg is a rich source of quality protein, important source of unsaturated fatty acids, vitamin A, E, K, and B complex vitamins, especially vitamin B. As a source of vitamin D, egg stands second to fish liver oil. Eggs are low in calcium and have no vitamin C. Due to low caloric value and easy digestibility, egg is included in the diet of older people. Egg protein and emulsified fat are most suitable for babies and growing children. Egg finds a place in everyone's diet. Egg is an excellent food and hence its quality is of great importance. Fresh egg have best quality. Quality of egg can be determined by many factors like size, shell, egg white, egg yolk. Fertile eggs gets deteriorated more rapidly than infertile eggs. Egg when stored at room temperature undergo physical and chemical deteriorative changes. Egg is considered as an important source of nourishment at affordable price. A variety of egg delicacy can be included in the diet. Thank you, learners.